Hello, I'm going to present a flowchart that is a model for doing basic classification or regression machine learning projects. Such projects usually come in 5 stages: data preparation, data exploration, analysis, and machine learning, and of course the write-up of the project to communicate the results. The first 3 stages are very similar to any quantitative methods project, with the subsequent modeling, the machine learning, being algorithmic rather than statistical. Data preparation. Successful machine learning requires the right data. Prime amongst these for classification and regression is a target variable that is essentially a set of historical outcomes, either categorical or numerical, that are to be correctly predicted by the machine learning model. Also required are a number of predictor variables that are likely to cause the target variable. Which variables to choose is likely to be influenced by current understanding of the phenomenon from theory, the literature, and current practice. Predictor variables may come from internal transactions data or from open external sources. Data exploration. To explore the data properly, you must first identify the different data types, such as numerical and categorical data, amongst your predictor and target variables, then structure the data accordingly. Quality checks are the first thing to explore. Find possible mistakes and inconsistencies. Evaluate the extent of missing data and whether this might compromise the machine learning. Then we explore basic descriptive statistics for all variables so that you can understand, for example, the range of values and their distributions. Evaluate whether outliers and extreme values might affect the machine learning, particularly if the techniques to be used require variables to be rescaled. Finally, we explore relationships within the data using mostly graphical techniques. We are particularly interested in the strength of relationship between each predictor variable and the target variable, often using a correlation coefficient. Those predictor variables that have a small or near zero correlation with the target variable can be dropped from the modeling, as their relationship with the target variable is near random and may render the machine learning inefficient. Data analysis. This concentrates on dimensionality reduction, though there can optionally be some significance testing and clustering. Sometimes clustering of cases using selected predictor variables can give useful insights, and cluster membership can be an optional predictor variable. Analyzing the need for any further dimensionality reduction is necessary to ensure machine learning models are parsimonious, can be more clearly understood, run efficiently, and minimize data collection and wrangling costs in a production version. Presented here are the steps for factor analysis, which analyzes the intercorrelation structure of the predictor variables to arrive at a final selection with which to create a machine learning model. Categorical predictor variables, such as days of the week, may need to be transformed into n-1 dummy variables to make sense in the modeling. If techniques such as artificial neural networks are to be used, the data will need to be appropriately rescaled, such as in the range 0 to 1. Finally, in this stage, the data need to be randomly assigned to train and test subsets. The machine learning models will be built using the trained data and tested for utility using the test data. Machine learning. The machine learning can now take place. The choice of machine learning method, and there are many, will be informed by theory, how the algorithms work, and the type of data. In general, categorical target variables are best modeled using classification algorithms, and numerical target variables are best modeled using regression algorithms. Some implementations of machine learning can handle both, It is usual to try more than one machine learning algorithm and compare their performance with the data. The baseline for comparison is the zero-rule model. That is, the prediction that ignores all the predictor variables. Having used the trained subset to create a model, the accuracy or otherwise utility of the model must be assessed using the test subset of data. There are a range of techniques that can be used to evaluate categorical or numerical outcomes. Improvements to the model can be sought for, by example, optimizing the parameters and using ensemble techniques. Be careful not to overfit the models. They may look accurate, but won't work well in production. Variable importance reports can be used to further explore model parsimony. After deciding which model has greatest utility for your application, a final model can be built using all the available data. Metadata needs to be created so that any user of the model can quickly understand what data and which methods were used to build it, and what the expected accuracy might be. The whole project needs to be written up as a report in sufficient detail so the results have validity and could be replicated by a reader. This YouTube channel will feature a growing number of videos on quantitative and qualitative analysis and on machine learning. They are based on 25 years of masterclasses. Subscribe and look out for them.